All right. Hello, everyone. This is a lecture on 8.3, which now we're going to test a claim about a mean. So we've already done this idea with proportions. Now we're going to do it with means, which we could also do it with standard deviation or variance, like how much variability do you have in something? But we're just not going to quite get to that. It's a chi-squared is what it's called. But let's talk about means today. So we are looking at testing a claim about a population mean where the standard deviation of the full population is not known. Okay, this is the world we're living in, and it is the most common. And we're going to use the t-stat area. On StatGrunch, it's a T. If we happen to know that standard deviation of the full population, not of your sample, but of that full population, then we use a Z. It's just different. So we talked about that in confidence intervals as well. So here's all the symbols. Know that this one too is of the population. Standard deviation. Okay, so we are still having that test statistic. So here's our formula for it. But again, we're not really using this method where we get our test statistic and then we look at our shape, right? And we're like, are we in this rejection regions? We could be on one side for left-tailed. Oh, I might be showing the wrong side for you. We could be on one of the sides, lower side, right, for left-tailed, upper side for right-tailed, and then, or we could be both-tailed, right? I Hopefully I said that right, because if you're left-tailed, it's going to the, yeah. Anyway, all of a sudden I second guessed myself. Okay, so just know that we can look at these critical values, look at this test statistic and see if it's in that rejection region at the ends or not. Or we just look at the p-value and we say, well, the probability of being in there, if it's low, the null is going to go away. And we have evidence in favor of the alternative hypothesis. So that's the way that we're going to learn it, is the p-value method. Okay, so this is the method I'm teaching. The critical value method I'm not going to teach. So we do always have requirements. So we're doing means, so our requirements are different. We're looking at having more than 30 again. So we've looked at this before because it's showing normality, right? Or if you have less than 30, then you need to know that the population is normally distributed. So we've looked at that before. Let's do some examples. So 40 people try Weight Watchers with the following results. Okay, the claim, Weight Watchers claim, Weight Watchers' claim that there's weight loss greater than 0. Okay, and we're going to use a level of 95. So we always start with, what is that null hypothesis? So HO, right, null. This time I need to use the mean symbol. I don't want to use a P for proportion because this is a mean. Okay, and then it says which value is in the claim. Okay, we don't want to look at our values up here, the 3 pounds, right? We want to look at what the claim is. The claim is anything bigger than 0, right? Or so we're going to have our null be equal to the 0, and our alternative will be that we have a weight loss greater than that 0. Okay? So everything in that hypothesis is going to be about your claim, not your sample, your claim. So we're going to see that this is our claim here, okay? And so our claim, it's going to be greater. So if we have evidence in favor of that alternative, or if we reject the null, so the P is low, then we have favor for our claim. We have evidence in favor of our claim. So the 95 will bring a significant level of 0.05. So we got to look if our p-value is below or above that. So let's go ahead and move to some StatCrunch here. I'm going to open this on my iPad, and it's kind of showing both. It's a little small. I'll reopen it up, but I think we're good and you could follow along pretty easily. So we're going to hit stat, okay? And look at that, all of our sections, right? We want a T-stat because we didn't say anything about the population standard deviation, nor do you usually have that. So T is where we go. So I'm going to hit T, and these are my options. One-tailed, two-tailed, or paired. We have, or one-tailed, I mean, one sample, two sample, or paired. We have one sample, and we have a summary. Okay, we weren't listing our data like the next question. So the next question will be a different. We're going to put in our mean. So the mean from our sample was 3. The standard deviation was 4.9. So the mean was 3 pounds lost. The standard deviation is 4.9 pounds in both directions, right? And then the sample size is 40 people. All right, then we go down here. We can't mess this up very easy because it's like it has to equal, and we are testing against 0, but we do have to change the second one to be greater. Okay, if you don't change that right, your T statistic and your P value will be off. So I'm going to hit compute, and we're going to write these now over here as well. So we see a T stat, and it is equal to 3.87. And our p-value is going to equal 0.0002. If I round to 2 places, I'm rounding to 0. So definitely a low value. And what I really like is look at the StatCrunch on there. You can see your null, your alternative, all of that in one big thing, which is really handy. So you can double check those. So let's go back to just seeing this so it's a little bit bigger for you to see. And if our p-value is 0.0002, is that lower than our significant level? Yeah, it's lower than most significant levels, right? So if it's low, the null must go. So how do we state that the null is going away? We would say we reject the null. So we have evidence in favor of the alternative. Is the alternative our claim? Yes. So we have evidence in favor of our claim. And our claim was that the weight loss is greater than 0. Okay, so we always say we have evidence in favor, evidence against. We never say we proved this or this is the way it is, right? We try to say we have evidence in favor or against, because there's so many little pieces for error in there, all the way starting with that sample and that sample, how it was collected. Okay, number 2 here. A group of students estimated the length of 1 minute without reference to a watch or a clock. So some of my students have done this idea for their project, for their second project. Okay, and the times are in seconds below. Use a 0.1 significant level that refers to 90%, right? Test the claim that these times are from a population mean equal to 60 seconds. All right, so let's set up our null and our alternative. So null alternative. Our null is always going to be equal to 0. Done. Better use your symbol for mean. Then it says for our claim, use this level to test the claim that these times are from a population mean equal to 60. So the claim is actually equal to 60. So this time the claim is the null. Well, if I don't have less than, greater than, or any of that in my claim, what do I use? Not equal. Because we don't know if people will estimate below or above. We're just proving it's going to equal 0. I said equal 0. Why did I say equal 0? It should equal 60 seconds. I apologize. 1 minute. I think my logic was thinking 0 minutes off, but really it needs to be 60 seconds. Sorry. Okay, so our claim is equal. So if we reject the null, then we're not going with the claim. If we accept the null or yeah, how do we say that again? Reject null. We don't say accept. Fail to reject. Thank you. I couldn't think of it. So if we fail to reject the null, then we have evidence in favor of our claim. So this time when I move over to StatCrunch, I have to put the data in that I have. So let's see, we went 70, and this doesn't want to it doesn't let me push enter on the iPad, but 83, then 36, 63. I wish I was on a computer. I would definitely type this up faster. 40, 23, 62, 61, 55. I lost my place. Wasn't it 55? 61, 65. That's why. It's like I can't find 55 because there isn't one 65. 51, 63, 70, 90. And it's so small when I'm reading it. I'm an old lady over here. 90, 88, 65. Okay. So there we go. Now the data's in. I'm going to close that. We can now hit stat, and we're still going to go to that T-stat area, right? So T-stat, but this time we still have one sample we have with data. Then you pick the column your data's in. I put it in variable 1, and then I have to pick everything else. So the hypothesis was it equals 60 seconds. And not equal to 60. Perfect. That's all built, ready to go. Compute. Okay, so my T-stat is 0.41. 0.41, and our p-value is huge. 0.68. Okay, so let's go back and make our conclusion. If we have 0.68 as our p-value and our significant level is 0.1, are we above or below? We're definitely at high. That's a high one, right? So if it's low, the null must go. So if it's high, I don't have a rhyme. I think I heard one somewhere. I was trying to remember. If it's high, then we fail to reject the null. Okay. There's like this one saying, it's like, let it fly, but it like let it go, but that's with the null. That wouldn't be this case. So if we fail to reject, we have evidence in favor that people could time a minute out. We have evidence in favor of that. So we favor the claim. I'm not going to write it out all the way. We have evidence in favor of our claim. All right. This next one, hopefully you're getting this idea. Yeah, and whether I fail to reject or I reject the null, it could be the claim or not the claim. So you'll have 4 things to pick from every single time. Fail to reject in favor of the claim, fail to reject not in favor of the claim. Those will be yours, and then the other way. Okay, a data set about speed dating includes like ratings, okay, of male dates made by female dates. The summary statistics, there was 181 people. This should be the mean. It just doesn't come through on the iPad really well. So 4.41 is the mean. Was this our like ratings? Where it's like 0 to 5? I think we're only doing to 5. And then the standard deviation is 1.86, significant level of 0.01, which refers to a 99% level of accuracy. The claim that the population mean of such ratings is less than 5. Assume that a simple random, I still don't know if our ratings go to 5 or 10. if they go to 10 and we got less than 5, this speed dating, oh, sorry, man, the speed dating got some bad rap from the women. Okay, what do we always start with? Our null and our alternative. And we know this is a mean, so it's going to be equal. And we know this part, right? This should be a given on the exam. You should be able to easily set up the null because it's equal. Watch your symbol, right? Proportion or mean. And the claim is less than 5. So this would be less than 5, and that has to be 5. Okay, and then it wants us to do all of our stuff. Which one's the claim is less than 5, right? So this is our claim. We're trying to show, oh my goodness, that there's a significant amount. So we know the ratings are already less than 5 that we got on our sample, but are they enough? Are they significantly enough to say they are less? That's what we're trying to get at, right? So split screen, bring this back up, close. This time, I'm just going to ignore that data. I'm going to do with summary in my T and then put in the data I have. The mean was 4.41. The standard deviation is 1.86. And the sample size is 181. Okay. And then we're testing against the level of a rating of 5, and we're testing, oops, not greater, less than. All right, hopefully I put everything in there correct. And then here's what we got. So basically, our p-value that we really are looking at is going to be 0 when we round it because it's less than 0.0001. So it's saying it's less than that. That's why that symbol has the less than. Okay, so the t-statistic, yes, we could list that, but I'm not really worried about it right now. You have to just put it in all of your homework, but for this one, we're like, all right, our p-value is basically 0. So it's definitely lower than our level of 0.01. So our significant level, so if it's low, the null must go. So reject the null. Those are our words. And we do have evidence in favor of our claim. Which is our claim. Okay, so we basically have evidence in favor of the alternative hypothesis. All right. Cool. Usually in class, I have people try the last one. So I'm just going to cut off my video here and we're just working on that same thing, but now we're going to be using that T area. Okay. And the Z area is like almost never used, only really with sample size. That's the only problems this book really focuses on, where you use that Z area. All right. You guys have a great one.